In this lesson, we're going to expand our definition of a rational exponent. So previously, we defined something like 25 to the 1/2 power, where this was always a 1. And we saw that this was the square root of 25. And so the answer was simply 5. But what if you have something like 2/3 or -3/2, where this fraction, the numerator doesn't just have to be a 1. So the definition that we're going to use is the n still means you're taking the nth root. So here you're doing it last, here you're doing it first. But this m means you're also raising x to the power of m. Here you're doing it first, and here you're doing it last. Let's try out this definition by looking at 8 to the 2/3 power. Okay, what this means is that we could first take the cube root of 8 and then afterwards square it. So again, the 3 really means we're doing the root, and this 2 means we're really doing the power. Okay, if we simplify this value, the cube root of 8 itself was 2, and then if you square 2, you get 4. And I'm just going to check this in a calculator just to make sure that this does match up. And yes, we do have a value of 4. You could have reversed this order. You could have first squared the 8 and then taken the cube root, and we'd still end up at the same answer. Okay, what about 25 to the -3/2 power? Anytime that we come across a negative exponent, that means we can write it as a fraction. This is 1 divided by 25 to the +3/2 power. All we need to do now is just figure out, well, what is 25 to the 3/2? And the way I'm going to look at this is by first taking the square root of 25, and then whatever I get, I'm going to cube the answer. So again, I'm going to this portion of the definition. So if I take the square root of 25, you get a 5th, but that 5 is cubed, and if you cube 5, you get 125. And so this is the answer. I'm going to type this into my calculator. That's 25 to the -3/2 power. So it gives me a decimal. The decimal it gave me was 0.008. I mean, this is an okay answer too. There's nothing wrong with it. Just know that these are in fact equivalent. This decimal and this fraction are in fact one and the same. The only thing to look out for with this definition is possibly your answer might be undefined. Like here, I have -9 to the 5/2 power. You could start by typing this into your calculator to see what happens. Okay, and it gives me, again, I get an error for this. So that means there is no answer. The thing that went wrong is, ultimately, you're dealing with a -9 to a 1/2 power, which means you're taking the square root of -9, which you cannot do. So this is not valid. This formula up here only works if the nth root is defined. And let's see, let's check out this other expression. So again, like this one didn't work because I have a negative and an even powered root. Here, I have 0 to the -3/4 power. If I made this a fraction that's 1 over 0 to the 3/4, the issue here is that your denominator would be 0, and again, you're going to get another error message because you cannot divide by 0. So these are only like two situations you have to look out for, which you would catch if you type these things into your calculator. You'd get some type of error message. So the thing to keep in mind is, for this definition up here, it always works if your answers if your exponents are positive numbers and you're allowed to take the root. But the second you have some negative values, you have to be careful about dividing by 0. And that is it for the definition. I wanted to look at a graph of an equation involving a square root by computing a couple of values within it. So here I have a grid, an x and a y axis, that I want to plot a couple of points for this function. And I'm going to choose these. I want to compute what is f of -4, what is f of -3, and maybe we'll get a couple of other values, maybe f of 0, and perhaps f of 2. So all I'm going to do is take these numbers, -4, -3, 0, and 2, and put them in place of x in my function and solve for the corresponding y value. So starting with f of -4, this is the square root of -4 plus 4. That means f of -4 is equal to the square root of 0, and that is 0. So here I have a point. When x equals -4, the y value is 0. So I'm going to put that right here. All right, I see what is happening at -4. I want to check out what's happening at -3. So I'm going to compute this value here. All right, for this one, that's the square root of -3 plus 4. So f of -3 is the square root of 1, which is just 1, and therefore f of -3 is equal to 1. So that's this point here. All right, a couple others. F of 0, okay, that's equal to the square root of 0 plus 4, which is the square root of 4, and that is equal to 2. So this is the point f of 0 is equal to 2, which is right here. And lastly, I chose to compute f of 2. That's the square root of 2 plus 4. So f of 2 is equal to the square root of 6. I'm not sure what this value is. Let's see. If I type this into my calculator, the square root of 6, I get about, well, I get a decimal that goes on forever. I think I have to maybe estimate this. Like this is roughly, I don't know, maybe 2.5. I'll leave it at that. So this is an approximation. So here I have that f of 2 is roughly 2.5. So when I go to graph this one, I go to 2, and I'm going to go up to 2.5. It's actually a little bit under that, so I'm going to put a value like right about there. So what all this means is, I picked a couple of points on purpose, so I ended up with integers. If you choose any other values, you might have to estimate where it's located, but I got this spot here. So I can see what my graph is going to look like. It's going to start around here, and it's going to go through these points, so it's kind of curving a little bit. So I see that the graph looks like this. And I'll just draw an arrow to say that this trend continues forever. So this is what the graph of a radical or root equation looks like. You might have to choose a couple of values that work out nicely within the function. And if you get ones that are not perfectly on integers, you'd have to estimate their location, but this is the graph. The last idea for this lesson is simplifying radical equations. So that means equations that have some type of root in it, like a square root or perhaps a cube root. So if I look at this expression here, I think it might be nice to go back to our idea of that a square root means a 1/2 power. So this really means 6 squared to the 1/2. And I know that really means just divide the exponent by 2, and so we get 6 to the first, or just 6th. So for this answer here, if you square root a squared, it pretty much cancels it because we're dividing this exponent by 2. Let's see if the same thing happens down here for the cube root of 2 cubed. All right, so for this one here, a cube root really means I'm taking 2/3 and raising it to the 1/3 power. So clearly I'm just dividing this exponent by 3, and so I'm left with 2. So this is kind of a nice thing that shows up with root or radical equations. If you have an exponent of 2 and a square root, it's going to simplify nicely because you're just dividing this exponent by 2. Here I'm going to have a cube root, and 2 is to the power of 3. I can divide that exponent by 3, leave me with a first that I don't have to write. This idea should work with variables too, as long as I add in the assumption that let's just assume all the variables represent non-negative numbers. Let's use this idea here in the square root of 36x squared. The goal is, if I want to simplify this, I want everything under the root to be raised to, hopefully a power of either 2 or something divisible by 2, like 4. And, I know that 36 is 6 squared, and x is already set up, so I have an exponent of 2. We, at this point, could write this as 6 squared times x squared all to the 1/2 power. The next step would be to divide each exponent by 2, and that leaves us with an answer of 6x. All right, let's try this again in the next problem, which is the cube root of 8x to the power of 6. Can I write everything with an exponent of 3, or at least something that is divisible by 3? This is the cube root of, 8. Okay, I know that's already going to be 2 cubed. We've run into this before. I have x to the power of 6, which is set up nicely. I know 6 is divisible by 3. For my next step, I'm going to write this as 2 cubed times x to the 6 all to the 1/3 power. This 1/3 is multiplied to both of these terms. 3 times a third is just 2 to the first, so I'll just put 2. And x to the 6th becomes x squared. So these are all pretty nice, and that's because the exponents that appear are divisible by the root, so they eventually just cancel at the very end. Last one here, I have the square root of 81x squared y to the 4th. It would be nice if everything was written with an even exponent. And you can do this. 81 is 9 squared. X squared, the 2 is even, and y to the 4th, the 4 is an even number as well. So this is really 9 squared, x squared, y to the 4th, all to the 1/2 power. I divide each exponent by 2, and so my answer is 9x, and then y squared. The takeaway here is anytime that you're dealing with some type of root, you're looking for exponents where you can divide by either, in this case it was a 3, or like in this case, which is a 2.